Hello everyone, and welcome to the Mathematecher channel. Let's suppose that we have four natural numbers that we note, m, n, and capital M and capital N, such that capital M equals 9m plus 2n and capital N equals 7m plus 5n. We would like to prove that the propositions 31 divide capital M and 31 divide capital N are logically equivalent. Therefore, in order to prove this logical equivalence, we'll prove the two implications that, respectively, states that if 31 divides capital M, then 31 divides capital N. And if 31 divides capital N, then 31 divides capital M. And in order to do that, we will be considering the two following equalities. First, we have 5 multiplied by capital M minus 2 multiplied by capital N equals 45m plus 10n minus 14m minus 10n, which equals 31m. And secondly, 9 multiplied by capital N minus 7 multiplied by capital M equals 63m plus 45n minus 63m minus 14n, which equals 31n. So, for our first implication, we will say that if 31 divides capital M, then there is a natural number that we note q, such that capital M equals 31q. Therefore, according to our first mentioned equality that put capital M and capital N in relation, we would have 2 multiplied by capital N equals 5 multiplied by capital M minus 31m. This means that 2 multiplied by capital N equals 5 multiplied by 31q minus 31m. Now, by extracting the number 31 as a common factor between the two terms of this subtraction, we find that 2 multiplied by capital N equals 31 multiplied by 5q minus m. This means that 31 divides 2 multiplied by capital N. And since the numbers 2 and 31 are co-prime, we deduce, according to Gauss's theorem, that 31 divides capital N. And this proves our first implication. Let's now move on to prove our second implication. So, as we did with the first one, if 31 divides capital N, then there would be a natural number that we note q, such that capital N equals 31q. Beside that, according to our second equality that put capital M and capital N in relation, we would have 7 multiplied by capital M equals 9 multiplied by capital N minus 31n. This means that 7 multiplied by capital M equals 9 multiplied by 31q minus 31n. Now, by extracting the number 31 as a common factor from the two terms of this subtraction, we find that 7 multiplied by capital M equals 31 multiplied by 9q minus n. This means that 31 divides 7 multiplied by capital M, and since the numbers 7 and 31 are co-prime, then we deduce, once again according to Gauss's theorem, that 31 divides capital M. And this proves our second implication. So, now that both of our implications have been proved, we can deduce that our logical equivalence is true. Thank you for watching. We hope this was instructive and enjoyable. See you next time.